Back in 1980, my mother wanted me to have a career, and I just didn't know the path to how to go about it. So what she did is she paid for me to attend a vocational school of mechanical design and engineering. Although not an engineering school, it taught me the basics on how to do mechanical drawings. My name is Kelvin. I was born in El Salvador, Central America. My father came from China. I'm a total mutt. In El Salvador, they had the Civil War. My mother, she decided to bring my sister and myself out of El Salvador to live in New York for a better life. Once I broke the news to my mom that I work in NASA, she was incredibly very excited. I remember one of my professors saying that a drawing is a means of communication between an engineer and the fabrication shop.
Good morning, sir. How's it going?
So here are the prints, and here's what we need to do. The bracketry, the top brackets is going to have two pieces. This is the top brackets. This is the left side.
And it's 125 stainless.
321 stainless steel, 19,190 bend.
And you only want one.
And my job is to make sure that we speak the same language, that it is clear, concise, and also that the engineer is clear in his intent of the design, and for the shop to be clear in what it needs to be produced for that design. The drawings that I produce varies here. Some are cabinets that I do that go into the airplanes. Others are just fixtures that go outside. In this particular project, this is a fuel line meter that is going to be put into the G3 airplane for the flex wing. And what it's doing is measuring accurately how much fuel it uses in any given time that it goes up in the air. The engineer designed the bracket. Once he did the 3D CAD model here, he gave it to me, and I produce all the drawings on this side. And my job, my responsibility is not only to do the drawings of the assembly with the bill of materials on the side, and also do the parts, every single part that is to be in that drawing, and dimension it and make sure that everything is correct. An engineer will do the design. Then after he completes the model, then he will give me that model, and I begin putting all the parts into the drawing, doing the dimensions, making sure that it matches the NASA standards and the ASME mechanical standards. And after I am done with the drawing, then I return the drawing to the engineer to be checked. Once a drawing is approved by the engineer, I will send the drawing to configuration management. They do a couple of things. One is that they will release the drawing into the system so the engineer can write a work order, so have the design be built by the machine shop. Second, and very importantly, is that they are the single repository for AFRC, in which they put the drawings and the CAD files into their system for safekeeping. If an engineer later on needs either the CAD files or a copy of the drawing, they will call them in order to get a copy. A typical day here when I come to work is I come in at 7 o'clock. So back to the 3D. Usually on Tuesdays, we have a meeting at 8 o'clock in the morning with my manager just to review all the projects, where they are, when they're going, and where's the due dates.
All right, Kelvin, what do we got here?
Okay, so we get this completed here. So we want to take a look at it.
It's going to be passivated.
I put this overall dimension here. So, but you want to know more dimensions between center holes. Mm-hmm. Or just from horizontal.
No.
After that, I just go about my business of working for the engineers and working on their projects and making sure that the timelines are met. What I like from here that it will be different than in the private sector manufacturing is that every piece that we make here in NASA AFRC is prototype, it's one of a kind. And I truly enjoy that. One is because, well, there's only one of a kind. And second, because it's not mass produced, therefore we put the best of our minds and mathematics into it to make it a reality.
All right, Kelvin, so I'm going to show you the primary locations
Okay.
where it's going to connect. So if you look right there, the harness. So let me go real quick right up here. So basically, we're going to connect from that screw to this screw right here.
Oh, okay.
So
Now I
that's
see
these
it.
2 points.
As I work with the engineers here in AFRC, it is very nice and brings a satisfaction not only to see their personal designs, that I do the drawings and check the drawings, that I have some kind of input, as small as it may be, and to see that it's going into a plane and doing research, because I know that that research is going to convey something to the scientific community and therefore reward humankind in a positive way. And knowing within me that I made a real difference, albeit small, but a real difference. One of the main points that I appreciate from doing some design is when I see something like this. When I began my career, it was all done in paper. There were no computers or no CAD models. So my appreciation is all the curves, there's no flat surfaces, everything has an in and out, everything is just flowing. And now that we have CAD, we can do that. But in the past, all this was done by pencil and paper. You have to be good in math and also to have the know-how on how to come up with the solutions to a need. The brain, yes, functions on both sides. The creative side on what it will look like, but also to have the math to correctly design it. There is a pride in it, knowing that as I go to museums and I see NASA and they talk about NASA, inside I always tell myself I work there. And I'm so thankful to make a difference as many others do. I find it very fascinating to be here, and I have learned a lot.